So let's start section 10.1 with problem number 11. And what we're supposed to do here is find the square roots of 49. Now we know that every positive real number has two square roots, one positive and one negative. So what numbers, when we square, will give us 49? Well, just because we know some arithmetic, we know that these numbers are going to be 7 and negative 7, because 7 squared is 49, and negative 7 squared is 49. So the two square roots of 49 are 7 and negative 7. And in problem number 11, the two square roots of 49 over 9 are going to be, well, what are the two square roots of 49? 7 and 7, and the two square roots of 9 are 3 and negative 3. So we are going to get 7 over 3, and the negative square root, negative 7 over 3. In problem number 22, we're asked to simplify this number right here. Now, this represents the square root of 64. 64 is a positive number, and we know that every positive number has two square roots, one positive, one negative. So 64 has two square roots, 8 and negative 8. But when we write this symbol over it, that's called a radical sign, we are indicating the positive square root. So out of 8 and negative 8, this represents the positive square root, which is 8. Problem number 29 asks us again to simplify this number right here. Now this means the negative of this number. So 324 has two square roots. It has the square roots being 18 and negative 18. So we're going to have 18 and negative 18, but this radical sign means just to choose the positive one. So I'm just going to bring this straight down and write negative. This part right here is 18, and the negative just comes down. So negative the square root of 324 is negative 18. In problem 39, we're supposed to find the square, right? Be careful here. The square, not the square root. The square of the square root of 144. Now in problem number 39, we are asked to find the square of this number. Now be careful. This is the square of this number, not the square root. So we have to read this carefully. Find the square of this number. So let's kind of look at what's happening here. What we're doing is, here's kind of an evolution of things. We're starting with 44, then we take the square root of 44, and then we square that square root. So taking the square root and then squaring the square root, those two operations just undo each other, and we're back here at 44. Problem 41, we're going to find the square of this number, right? So let's square this number. So what we're going to do here is we're going to square negative square root of 39. All right, and we know that when you square a negative, you get a positive. So this result will be positive. And when you square a square root, that radical comes off. So we're starting with 39, take the square root, square it, so we're right back at 39. Squaring with that negative makes it positive. So we're going to end up here with just 39. Now we're going to find the square of this. Well, it's the same idea as what we did back here with square root of 44. When you square the square root, the radical comes off. So what we're going to get here is this thing is going to be 3x to the 7th plus 5. We can work our way through this. Let's just trace our steps here. We start with 3x plus 3x to the 7th plus 5. Then we take that square root. Then we square that. And so we're right back to 3x to the 7th plus 5. In number 49, we're given this number here. We're given the square root of 11, and we're asked to find or determine, is this rational, irrational, or not a real number? Well, I'm going to claim that this is irrational. And I'm going to say it's irrational because, now I'll use my calculator to help me with this, but the square root of 11 is about 3.317, And this number is not a whole number. If the square root turns out to be a whole number, it's rational. But if it's not a whole number, it's irrational. So just a quick little example. If we were to do this one here, the square root of 9, well, that's exactly 3. And 3 is a whole number. Right, that's a whole number. No decimals, no fractions there. So this one is rational. But if it turns out that there's a decimal part, it's going to be irrational. In problem 59 here, we're given the square root of 80, and we're asked, between which two numbers is this? Well, we don't know exactly the square root of 80, right? It's not a whole number. So I'd like to estimate this number. It's between which two numbers? Well, let's do this. Let's look at this square root of 80. Now, what numbers around 80 do you know the square roots of? So if I take one below it, what number do you know just the square root of just below 80? I think it's probably 64. So if we take a 64, that would be 8. Now, the first number that I know above 80 that I know the square root of would be 81. So I know this. The square root of 81 is 9. Now here's the relationship that we have. We know that 64 is less than 80, and 80 in turn is less than 81. And if we put square roots on these, we'll get the square root of 64 is less than the square root of 80, which we don't know, which is less than the square root of 81. And then I can actually take these square roots, getting 8 is less than the square root of 80, which is less than 9. That's what we're asked for. And you know, I meant to do this one back here. I meant to do problem number 35, but I just passed over it, so I'm going to do it right now. In 35, we're asked to simplify this number right here, square root negative 25. Well, this is the square root of a negative number, and we don't take square roots of negative numbers. So I'm going to write not a real number. We don't take even roots of negative numbers. If I do this, like, what would I get? If I put a negative in here and square it, I'm going to get positive. And there's no way I can take a real number, square it, and get a negative number. So square root of a negative number, not a real number.